Good evening, everyone. This is Bremster, and today I'm coming to you with a puzzle called Counting Primes by Isamook. Sorry, I shouldn't have said the name like that. Isamook. It's Isamook. I don't know how else to pronounce it. It just sounded a bit weird when I said it. Before I get on to the puzzle, there's a couple of things I wish to say. First of all, new Patreons. I haven't done a new Patreon announcement in a while. So there's 3 people who have joined my Patreon that I'm aware of since I last did a Patreon announcement. Sarah Williams-Nash, Leah Adams and Keith. Thank you for jumping on board. And I've also got a couple of YouTube members who've jumped on since I announced that. Now, I'm recording this before the first announcement I made a few days ago of my YouTube members. So these are people who've just seen the join button and jumped on board. So Scott Brooks and Gitanjali Dougal. So thank you for jumping on board without even knowing anything about it. Really do appreciate it. Let's have a look at Counting Primes by Isamook. Of course, go check out the community section for the voting that's going on for Best of 2023. I don't know if I'm going to do it. I don't know what I'm going to do next year. People seem to enjoy this. I'm getting a lot of positive feedback, but it's a lot of work. And I don't know. I don't know if it's worth it. We'll see. So, Counting Primes by Isamook. Normal Sudoku rules apply. So in every box, in every row, and in every column, the digits 1 to 9 must be placed without repetition, and digits in circles count the prime numbers in the surrounding cells, including itself. All circles are given. Each digit except 9 is in at least one circle. That's interesting. So, okay, I'm going to restart the puzzle. Let's give this a shot. So, how many this digit is counting how many primes are in this box. So, we've only got the digits 1 to 9. 1 is not prime, mathematically defined. 1 is not prime. 2 is prime. 3 is prime. 4 is not prime. You can divide it by 2. 5 is prime. 6 is not prime. You can divide it by 6. 7 is prime. 8 is not prime. You can divide it by 4. And 9 is not prime. You can divide it by 3. So 2, 3, 5, and 7. So in this box, 2, 3, 5, and 7 are in there. So this is a 4. And any central cell is a 4. This is also a 4. So, okay. Now, I can also highlight primes because 2, 3, 5, and 7 are prime. So let's mark prime as yellow and non-prime as blue. These are not prime. Not prime. Okay. So, this can count a maximum of 4 primes because the maximum number of primes I could put into a box is 4. However, I can't make this 4, so the maximum it could count is 3. So this is counting 1, 2, or 3 primes. Because if it was 4, it would have to count 4 primes, and it can't count 4 primes because it could only see 4 cells that could possibly be prime, but I can't put 4 there anyway. Similarly, this can count a maximum of 4 primes because the maximum number of primes I can put into a box is 4, but it can't be 4. So this is 1, 2, 3. This one could potentially see 5 primes because I could make all of those prime because that digit could be that digit or even that digit. But if, not sure if that 5 messes it up. I don't think it does. Like that digit could go there and then these could all be different prime. Yeah, don't know. But this has to see 4 prime. This can't see 7 primes. So this can't be a 7. I mean, the maximum it can be is 5. So this is 1, 2, 3, or 5 because the maximum number of prime digits I can put into these 6 cells is 5 because that's not prime. So this is 1, 2, 3, or 5. So there's no 7 in there. There's no 7 in there. There's a 7 in one of those, but this is not a 7 because again, the maximum number of digits this could be. So this is 1, 2, 3, or 5. So there's a 6, a 7, and a 9 in those, but I know 7 is in there and I know 7 is in there. Okay, I know 8 is in one of these 2. Can I do more with 8s? Now, if this was 8, 8 is not prime and all of those would have to be prime, which might be possible. If this was a 1, all three of those digits would have to be prime. They'd have to be 2, 3... No. Hang on. No, if this was a 1, then there'd be 1 prime. 1 is not prime. If this was a 1, then there'd be 1 prime in those. And therefore, all three of those would have to be prime. If this was a 1, then there would be... I don't... If this was a 1, then all of these would be non-prime, and these would be prime. These would be 3, 2, 3, and 7. There's... This is 1, 2, or 3, because the maximum number of primes I can put in here... Wait a minute. Could this be 3? If this is 3, it would count itself. Now, all circles are given, which is what's weird. I don't know how to use that. I also have to put every digit except 9 into a circle. Wait a minute, I need to put 8 into a circle. Each digit except 9 is in at least one circle. Well, I can't put 8 into any of these. I can't put 8 into anything in a border. Can't put 8 into either of those two. Can't put 8 into any of those. Can't put 8 there. 8 or there. 8 is in one of those two. And that's not an 8. So, okay, 8 can't go into any of those circles or any of those circles. 8 can't go into any of those circles. 8 can't go into any of those circles. 8 can't go into anything on a border because I can't surround it with 8. 8 can't go there. 8 can't go into any of those circles. That leaves 2, and that can't be an 8 because it'd have to be surrounded with all primes, and those aren't prime. That is not an 8, and that is an 8, and all of these are prime. That is crazy. And 8 is not prime. That's crazy. So these are all from 2, 3, 5, and 7. That's not a 5. Now I need to put 7 into circles. Now, I can't put 7 into anything on a border. I can't put 7 into those or those. So the only possibilities for 7 are those two. But I can't make this a 7 because the maximum is 1, 2, 3, 4, 5, 6. So that's not a 7. That is a 7. That's really weird. And so these are not 7. This is 2, 3, 5. 5 is in one of those two. There's no 2, 3, or 5 there. This is a 1, and 1 comes out of those. Now, 1 is not prime. The 7 means this isn't the 7, this is the 7. 7 is prime. 7 is prime. If this was a 3, both of those would be... This can't be a 3 anymore, because if this is a 3, both of those would have to be prime, and then that would be prime, but this would be 2 or 5, which would be a 5th prime in the box. So if this is a 3, both of those become prime. 2, 3, and 5. 2, 3, and 5 are all prime. So if this is a 3, both of those have become prime, and I've got 5 primes in the box. This is a 2, which is prime. This is not a 2. This is 3 or 5. There's no 2 here. This is... 5 is in one of those two. This is a quadruple. 4, 6, 8, and 9. Well, I can't put 4 or 8 in those. So this is 6, 9, and this is 4, 8. And this is a 3, 5 pair. Those are prime. These are not. And those are the two that sees. But this now sees it's 1 prime there. So these are not prime. Four and 8 are not prime. This is not prime, but this has to see 7 primes. 1, 2, 3, 4, 5, 6, 7. Except 7 sees itself. So I've still got one more prime to find in order for this to not be a problem. Like this could see 1, 2, 3, 4, 5, 6, 7. Ooh, I made a mistake. I made a boo-boo. I have to roll back to where I put that 7 in, because that could have been 7. And this could have been 7. 7 is in one of those 3. I'm terrible at these. 8 worked because 8 is not prime, so everything around it had to be prime, but I can't do it with 7. So all of the stuff I've done in the last, 5 minutes is all wrong. Except I know 8 is here, because 8, 8 looks up, putting 8 in one of those 3. That can't be 8, and 8 sees that. So this is actually not prime. But this doesn't stop that being a 7. Puts 8 in one of those 2. Damn it and blast. So I need to make other deductions. I need to make better deductions. The only reason it broke is when I realized that these could be 7. Like, all of this was good, except for I realized I'd made a boo-boo. I had boo-booed. So this could be as high as 7. So you can never put 9 into a circle, which is why every digit except 9 has to be placed. Wherever you put 2, it's going to see itself and one other prime. Is the question about where 6 can go. 6 can't go here. 6 could go there, though, because I could make all of those... No, I can't make all of those prime, because then I'd have 6 primes in this box. So this can't be 6, this can't be 6, this can't be 6, this can't be 6, this can't be 6. That could be 6. That could be 6. That can't be 6 because it's prime. That can't be 6. That could be, that could be, that can't be, that can't be. There's a lot of digits in here that could be 6, so I need to find something else. Now this already, if this is a 1, all of those are prime. This becomes 2, 3, 7. I can't make all of those prime. If this is a 1, all of these are non-prime, and these all become prime, because those would be the 4 prime numbers, but then I'd have 5 primes. This is not a 1. So it's 2 or 3. If it's 2, then those are both prime, and I've got 2 primes up here, which would give me all of the primes in the column. If it's 3, then there's this and both of these are non-prime. Nope, I am not getting it. This is 7. I need 6 primes around here. If this is 7, 1, 2, 3, 4, 5, 6, 7, all of those become prime, which would basically mean both of those become prime, which would make this a 9. This would make, no, this from 2, 3, 5, 7. So this would be 2, 3, 7. And that would be a 1, which is where I was before. That's if that's a 7. If this is a 7, this is a 1 because this becomes 2, 3, 5, 7. If this is a 7, though, then all of these become, hang on, 1, 2, 3, 4, 5, 6, 7. But that would be 1, 2, 3, 4, 5 primes in the column. This is not a 7. So 7 is in one of those two. If 7 is here, all of these, if 7 is here, 1, 2, 3, 4, 5, 6, 7, and all of those are prime, and if this is 7, all of those are prime, either way, that is prime. This is always prime. If this is 7, 1, 2, 3, 4, 5, 6, 7, this is prime, and if this is 7, then it's prime. This is always prime, which means always these are not prime, which means this is 1. This is a 2, 3 pair, and 2 and 3 are both. And that's the one it sees. That's the correct way to get that deduction. Now, one of these has to be a 7. So that is not a 7. That's a 2, 3 pair. So this is a 7. Because 2, 3, 5 are seen. That is a 7. Now, I don't know that this isn't a 7 because it's now been seen at least once, but I've now found a 7. These are not 7, 5 is in those. That's the correct way to do it. That's beautiful, by the way. Assuming I can keep solving the puzzle. This is by no means certain. This is not 7, this is 7, which means it's prime. This can't see 3 primes now, so this is 2, which means this is 3, which is good because it sees them. This is 2, which takes 2 out of there. This is 3, 5. There is no 2 there. There's no 1 there. This is prime because it's 3 or 5. This has to be prime, so it's also 3 or 5. And we're back to the situation where 1, 2, 3, 4, 5, 6, and 9 go into those. And this is 1, 2, 3. This is a 4. I'm back where I was, but correctly proving why this had to be a 7. I'm happy about that. Now, either both of those are prime, at which point they would have to be 2 and... These can't both be prime. This can't be a 5. If this was a 5, both of those would have to be prime. But that can't, all of these are non-prime because all 4 primes are already in the row. So this can't see 5 primes. That's the 3, that's the 5. This now sees 3, so this is not prime. And now I need 2 more primes in the box. Those are prime, and those are 2 and 7. This can't see 7, that sees 2, which takes 2 out of there, and 7 comes out of all of those. This is a 2, 3, 5, but I've seen all the primes in the column. These are not prime. Two has to be in one of those two, which puts 2 down here. Yay party. 1, 2, 3, 4, 5, 6, 7. These have to be prime for the 7 to be met. And that's all 4 primes in the row. These are not prime. This now has a maximum of 2 because these are not prime. This is a 1 or a 2. And it can't be 2 because if these were all prime, that would be 5 primes in a row. This is a 1 because only one of those can be prime. One of those must be prime, which will make up all 4 primes. These are not prime. I've got all 4 primes in this box, so these are all not prime, which means this isn't a 2 or a 3. This is a 1. Only one of those can be prime. But these are 2, 3, 5, 7. 2, 3, 5, 7 being the magical bullets in this puzzle is weird and I'm not used to it. There's no 3 here. There has to be a 7 in one of those two for the rows, so that's not a 7. Neither of these are 2. But I can get more of these. This sees 1, 2, 3, 4, 5, 6, 7. This is a 7. So both of these turned out to be 7. Can I figure out what this is? It could be 1. It can't be 2, 3, 4, 5, 6. 1, 6 or 9 only. And I think that goes there. So that's 1, 6 or 9. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 1, 6 or 9. Those are the same digit. Yeah. One of those has to be prime, but only one of them can be prime. So one of them is not prime, so both of these have to be prime. Otherwise, I'm not going to get 4 primes in the box. So this is not 2 or 7, so it's 3 or 5. If it's 5, all of those are prime. Maybe. This is only 2 or 5 because they're the only prime numbers it doesn't see. Fascinating. Where is 4 in this box? It's not in those, it's not in those, it can't be in those. That is a 4. In fact, this is a triple. What are the non-prime digits? They're not 2, 3, 5, 7. So it's not 1, it's not 2, it's not 3. 4, not 5, 6, not 7, not 8. So this is 4, 6, and 9. There's no 4 there. So 4 is in one of those two. Now 4 is not prime. So one of these two is prime. Not sure? Only one of those is prime, but only one of those two is prime. So whichever one of these is prime completes the primes for the column. So if that's prime, all 3 of those are prime. Actually, all 4 of those are prime. This is 5 non-prime digits. All 4 of those are just prime. So this is 2, 3, or 5. But it already sees 3 digits. It already sees 4 digits. This is a 5. So this is a 2 and this is a 3. I found something. There's no 5 in those. This is a 2, 3 pair. This is a 7. The 2, 3 pair looks like making this the 5 and this the 3. That puts 3 down here with actually, I just know these are 2, 3, and 7. I know what they are. I know what they are. 5 goes into those, but I can't put 5 there because the maximum number of prime digits in those is 3. 1, 2, 3. So that's not the 5, which means this can't be 2, 3, 5, or 7. It is not prime. But I need a 4th prime digit. That right there, see that one there, is prime. Now, this is a 3 or a 5, which completes the primes for the column. I figured something out and I'm happy about it. But 5 in this box is in one of those two, which means this is the 3, this is the 2, this is the 5, this is the 3, this is the 2. This is a pair. 1, 2, 3, 4, 5, 6, and 9. This is a 6 or a 9. This is just a 1. This is not a 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the 8. And these are 1, 6, 9. And the 1 has to be in those two, so this is not a 1. That gives me another 6, 9 pair. There's 6, 9 pairs all over this puzzle. This 3 makes this 5. And this is a pair. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are 1 and 4. Now this one is done. It sees all of its... Do I want to start marking off ones that are done? Maybe. What colour do I want to use for that? Red. This sees 3. That's a bit garish, isn't it? That... do I want to mark ones that are not done? Like, this one's not done. This one's not done. This one's not done. That one's not done. But it will be when I put a 5 in one of those. So that one's done. This one's not done. This one's not done. That one will be done as soon as I put a 5 in. All of those seem to be done. All of those seem to be done. So those are the 5 circles I actually need to care about, I think. So I know one of these 2 digits here is prime. If it's there, it's a 3. This already sees 2. So only one of those digits can be prime. But 2 of those digits are prime. Because I need to put a 2 and a 3 into those. But one of those is prime, which means I can only put one prime digit over here. I can only put one prime digit over here. But is there any reason I couldn't put it in here and that not be prime and that be prime? Not that I can see. There's an 8 in one of those 2. Okay, so I'm 4 in one of those 2, but this is not the trick here. Now this is a maximum of 4. This is a maximum of 4. So this is 2, 3, or 4, and it can't be 4. Oh, that's cool. That's really, really cool. If this was a 4, all of those would have to be prime. But 4 isn't prime, so the maximum it could see is 3. This is 2 or 3, which means it's prime. So this is the prime, this is not prime. The 3 makes this the 2, which means this is not 2, and this is not 2. Now, one of these is prime. But I need to put a 7 down here now. This is 1, 6, or 9. Now this can see a maximum in all of those cells of 2 primes. So this is 1 or 2 and it can't be 2. This is a 1. And this is not prime, which means that is not 5. This is 5 and is prime. And that circle is done. Making progress. So these are not 1, 2, 3, 4, 5. These are 6, 8, and 9. And there's no 6 there. But the 1 looks up taking 1 out of there. This is a 1. The 8. Why did I say there's no 6 there? Let's do this again. This is 6, 8, or 9, and there's no 8 there. This is a 6, 9 pair. Let's get the pencil marks right, Bremster. So this sees at least... If I make this a 3, it's automatically seeing 4 primes. So that's not a 3. This is a 2, 3 pair. Because if I put a 3 here, it would be seeing 1, 2, 3, 4. That's not going to work. This is a 2, 3, 4, and both of those are prime, which means this is not prime. But it sees 4 already at least. So this is 4. It can't be 5. It can't be 4. It sees 4. It can't be 5. This is 6 or 9. It can't be 9. There's no way you could put 9 in it. This is the 6. Every circle needs to have a digit. This is the 6. I have a 1. Do I have a 1 in a circle? I have a 1. I have a 2. I have a 3. I have a 4. I have a 5, I have a 6, I have a 7, and I have an 8. Didn't use that often enough, but I've now got it. This is my 6. This 1 is done. 1 and done. So I need to get 2 more primes in there. No, 1, 2, 3, 4. Yes, I need to get 2 more primes in there, which means these are not prime, because that will be all 4 primes for the box. So this is not 7. This can't be 1, 6, or 8. So it's 4 or 9 only. One of the primes is in one of those two. One of the primes is in one of those two, which makes sense because I know that will be 1 in there, 2, 3, and 1 in there. So there is a prime down here, and it's 2, 3, or 7. If it's there, it's 3. If it's there, it's 7. Haven't figured that out yet. But I need to get 2 more primes into this column. But if I make them both of those, this 3 will see 1, 2, 3, 4. So I can't make both of those prime. So only one of those could be prime. So 1, 2, 3, that must be prime. That there must be prime. But I have to put a prime in one of those two to complete the row. So there's a prime in one of those two, and there's a prime in one of those two. But because there must be a prime in those, that'll be all of them for the box. This here is not prime. One of these is, which means one of those is. If that's prime, that's prime. If that's prime, that's prime. I've got an X-wing on primes. But I can't put 5 in any of those. So this is 5, this is 7, which means that is prime, because once this is 5, the only place I can put 7 in the box is there. These are both prime. This is not prime. This is not 5. This is 5, which is the final prime. This is a prime example of a prime Sudoku. This is 4, 6, or 9, but it can't be 4. So I've got another 6, 9. Oh, this 6 looks up making that 9 and that 6, which means that's not 6. This 6, 1, 2, 3, 4, 5, 6. The 6 is done. The 3 is done. The only thing that's not done is this 2. And I know one of these two has to be prime. I am failing at the Sudoku, but I'm having a blast failing at this Sudoku. 1 is in one of those two. Seven is in one of those two. 3 is in one of those two. 3 is in one of those two. Right, this 7 makes this 3 and 3 comes out of there. This is a 2-7 pair. That hasn't done it. This has not helped me. Primes are either in those two positions or those two positions, and either of them is going to fulfill that 2 clue. So I need to do Sudoku to get it from here. So the clues are basically done, but I'm going to keep that 2 clue to resolve it. Okay, what am I missing? The solution. So this is 1, can't be 2, 3, 4, 5, 6, 1, 6, or 9 only. So what is it? 1, 4, 6, 8, 9. So this is 4, 1, 4, 6, 4, 6, and 9 go into those. No. What am I missing? These are 1, 4, 8, 9. There's no 1 there. Oh, there's no 6 there. There's no 6 there. There's no 1 there. That's 9. So this is 8. This is 4. There's no 4 there. The 4 makes this 9. There's no 9 here. This is a 1, 8 pair. The 1, 8 pair, well, there's 8. That's 1. That's 8. That's what I missed. I missed all this Sudoku that was happening down here. The 4 looks up making this 9, which means this is 6 and this is 4. The 9 makes this 6, which makes this 9, which makes this 6, which makes this 9, which makes this 6, which makes this 9. It also makes this 9, which takes 9 out of there. The 9 comes out of there. These are 1, 4, and 6 in an order I can't quite see yet. There is an 8 and a 9 in this column. So this is the 6. This is the 9. So in this row, 2, 3, 6, 7. There's no 2 or 7 there. There's no 2 or 3 there. So this is 4, 6, or 7. There's no 6. And this is 1, 3, 6. There's no 6. Quite confused. Quite confused indeed. How does this resolve? 7, 2, 3, 6. If this is 7, this is 6. This is 4, 1, 3. If this is 7, this is 6. 1, 4, 1, 3. That's fine. If this is 6, 4, 7. How does this resolve? All circles are given. All circles are given. That, man, I've got this far without all circles being given being an issue. If this was a 3, how do I prove that I've not had... If this was a 3, it would see 3 primes. This can't be a 3. This has to be a 2, and this has to be a 3. How do I prove that I don't have that anywhere else? That 3 is a circle. That's the problem. If this was a 3, it would need a circle, and it doesn't have one. So the 2 here makes this a 7 and this a 2. The 7 means that's a 4 and that's a 7. The 4 makes this 1, this 3. These are both prime. This is 6. These are non-prime. That there, this 2, 3 pair being resolvable by if this is a 3, it would need a circle and it doesn't have one. That's the trick, and I think a few people are going to be like me and miss that. That easy miss. But now the count looks correct. Because this 3 sees 2, the 5 sees 1, the 5 sees 1, the 7 sees 2, the 2 sees 3, the 5 has a circle, the 2 sees 5. It's all good now, I think. So now I can just finish this off with 6, 1, and 4, and that's the correct solution. 37 minutes 58. Okay, I took way longer on that than I probably should have, but it took me way too long to count the primes, and I missed some fundamental rules. First of all, the all digits 1 to 8 had to be placed in circles. It took me a while to realize the ramifications of that. And then, of course, what was going on here, it wasn't until I hit the deadly pattern and went, wait a minute, and then I thought, wait a minute, all circles are given. And if I'd used that earlier, I probably could have resolved some stuff faster. When you solve this and realize that rule, you'll do better. Thanks everyone for watching. I hope you enjoyed the puzzle. I know I did. This was a lot of fun. I loved this one. Even forgetting the rule, it was like when I needed it, I remembered it, and that's fun. Is it a perfect demonstration solve? No. You come here to laugh at me, right? I do. Thanks everyone, and as always, good luck with your solving.